Hello, my friends. I am just getting set up. We may have some background music or background sounds with neighbors cutting fence posts, but yeah, let's do this. Get some music going. Get our project up. There we go. Bump up the text. Let's get into our where are we? I think we're in the built-ins. We're still working on some tests here. This is where we left off. And I need to bring over my terminal so that I can run tests in. Cool. All set. Oh, I guess I wasn't even sharing my screen yet. So there we go. Everything is ready to go, I think. Unless we're going to freeze. Cool. That's fun. Love when we freeze. It's great. Good stuff. Great. Still frozen. Awesome. Fun times. I don't know what happened there. Apparently, apparently Chrome just crapped out on me. So let's see if we can try sharing our screen now. Looks like it's working. Great. We have our code up. Let me just make sure that I actually am streaming. Patiently waiting. Okay, cool. Looks like we're live. Streaming to Twitch at least. Great. Thank you. Buy followers, primes, and viewers on Mountain View. Man, who is this? Real papyr serected? I don't know. What up, Ben? Happy to have you here today. Have you been around for any of the other testing streams? We're trying to write some tests. Yeah, I figured. Okay, cool. Well, you got any questions you want me to get into before, or are you just hanging out? Or you got something else you want to work on instead of testing? Because I'm happy to do that as well. Just hanging. Man, I don't think you were on the stream where we did the actual NVIDIA screen reader test with the forecast app. It was pretty good. I was pleasantly surprised with how well I could navigate around and get the screen reader telling me what I was trying to do. And yeah, you have much experience with the screen reader testing, like hands-on screen reader, only using the keyboard to navigate and only hearing what it's telling you? It's intense. It's intense if you've ever seen someone that uses a screen reader like 100% of the time. Yeah, voiceover seems pretty cool. I wish when I see other people that are doing screen reader tests and you have the combination of voiceover and whatever the Mac thing is that shows you what keys you're actually pressing. That's nice. There's probably something like that for Windows, but I should figure that out. Anyway, what we were doing, Keycaster. I should look that up. Let's see. Keycaster Windows. Oh, we got some happy tunes. Yeah, Keycaster. I'll get to that later. Okay, so we're not really looking at the front end so much. We're just trying to run through some tests. So we have two. Thank you for sharing that. We have two types of tests. I'm going to showcase this first one. which, oops, that's not it, which we're not going to use as much because what it is a coverage report. And what coverage reports do is they show you how much of your code base is covered by the test that you've written. And the reason, like, it's pretty snazzy, but the reason why we're not going to use it so much is because, as you can see, it's like really slow. And even, I don't know if it's my computer or the fact that I'm using WSL or whatever, but even getting Vitest tests up and running the first time is slow, at least on my machine. But you can put it in this watch mode that every time you make changes, then all of the subsequent tests that run, it's like 9 milliseconds, so super fast. All right, so here it ran, it took 30 seconds. I should maybe ask the guys about figuring out how to make that boot up faster. But I've got 4 test suites. They're all passing. I've got 40 individual tests, and then it should be like trying to do the actual, there's the code coverage. Yeah, so when you run a coverage report, you'll get usually this little table that shows all of the files. You can have it configured so it shows all of the files in your project, or just all of the ones that have test coverage. So right now, this is just the files that we have written tests for. I kind of prefer it the other way, where it shows me all of the files, and then we'll have a bunch of red or red zeros around here because most of the files are going to be untested to begin with. But the cool thing is it shows you all of these files, and then it shows you these different categories where you have like all of the statements that are made in your files and how many of those statements are covered by the test that you've written, all of the branches. So branches are going to be when a branch in logic occurs. So if you have an if statement or an else statement where it can either go this branch or that branch, right? If you have the more branches you have to test like the different conditions that are possible. So this is how many of those branches are covered. And then functions is obviously, well, I don't know if it's obvious, but if you write functions in your test or in your files, you're going to want to make sure that those functions are tested. So here I have most of my files are 100% covered, but one of them is just 93%. And then the actual line. So every single line of the file, how much of those lines are tested. So these are just different ways to see what those tests, or see how much of your code is actually tested. So if I look at that, I'm seeing that URL search params is 100% covered, which I don't think is actually true because I haven't actually written the test for it. But then again, URL search params really doesn't need to do much. Like it just exports the URL search params that's built into Node. So we'll see. The thing I was going to get into today, or the thing I got into last time, was mocking. You know what mocks are? I could go into mocks again. It's basically intercepting some functionality and replacing it with your own custom functionality so that you can, yeah, okay, cool. You're familiar. Yeah, mocking is fun, is interesting because a lot of people are like, you shouldn't create mocks for whatever reason. Because the reason you shouldn't create mocks is because here I'm mocking node fetch, right? So I'm saying, hey, when you try and use the node fetch library, instead of using node fetch, just use this fake function instead. And the reason why that's a problem is because let's say the node fetch library changes and the API, like the surface area of the API changes. Well, if I mock it, I'm actually going to be intercepting any time that I import that library, which means that my mock can you can end up with a disparity with how the mocked function works than how the actual imported function works, which can lead to false negatives, like your tests will pass when they actually should be breaking. So that's why people don't like mocks. What you can do instead, if you want to avoid using mocks, you can write your code in a way that's like, well, let's just follow dependency injection. So you can say, hey, I'm going to write a function that says like make request, right? And it takes a URL and it says return, we'll just say return fetch with that URL, right? So that's what my function can do. Well, now this function has an external dependency on this fetch thing, right? And so if I say like const or import fetch from node dash fetch, right? Here's a good example where we're saying this function now is dependent on some external piece of logic. Well, with dependency injection, you can make this test easier because this is kind of difficult to test because now my test is dependent on some third-party library, which may change or may behave differently or whatever. So it may have something. It's something that I have no control over. So with dependency injection, what you can do is you can say, well, for this function to work, let's just say, right. And so this, how this example would work is like, let's say make request to https://austingill.com, right? That's how that would work. So with dependency injection, you can say, well, anytime that I'm going to have a function, instead of having external dependencies, let's call the function with everything and provide every dependency it needs. So we can say like HTTP tool, whatever. And then we can say, well, in order to make the request, we're going to call HTTP tool, whatever this is, and we'll pass it the second parameter. So now I can write tests for this function that is easier to test because in my runtime environment, I can provide fetch. So I can say, hey, if I want to make an HTTP request, use fetch and pass it to this, right? So when I'm in my runtime environment, I can call it like this. And then when I'm in my test environment, I can say make request with, well, we're going to say like const fake fetch equals bi dot function. So if you're not familiar with mocking, like mock libraries, it might be too much for me to go into since we're just talking about dependency injection. But if I'm in a test environment, I can write my test such that it looks like this. And now notice how make request is still going to work exactly the same, but it's no longer dependent on fetch or node fetch or whatever. It's just going to take whatever function we pass in and call it with whatever the second parameter is. So we can inject our dependency here in my testing environment. I can say, well, let me use this fake function. And then I can just say, like expect fake fetch to have been called with that. Really easy to write tests if you follow a dependency injection pattern. I also generally don't for a lot of my code, and I use mocks a lot. It's just two different approaches. I like the mental model around not doing dependency injection. But, there's a course for every horse, right? Cool. So now getting back to the issue at hand is I need to mock a global. So I want to look at like just mock global APIs. Let's see if I can do this. URL search parameters. Let's call this something else. Search params. We'll call it that. That's complaining because variable search params should be named search parameters. Yeah, okay. Thanks for the help, ESLint. And then what I'm going to do is try and say global dot URL search params equals console log. So let's try this. And you're just going to complain because or yeah, I guess that's not technically right. It's going to be a function that takes some whatever params and calls console log those params. You're still complaining because some other reason. Yeah, void is not assignable. Okay, that's no match for the signature. New. I feel like this should still be okay. So now I'm going to try calling my function or calling my tests. So here we have a different npm command. The coverage command is going to actually generate this nice chart of coverage report stuff. It also is going to actually write to the file system. So I can create like I can deploy a website with my coverage report in it if I want to, which is nice, but we're not going to run that one. What we're going to do is just this npm run test instead, which is just going to call Vitest. And what Vitest does is it will run a watcher on your file system. And when you change files or test files, it will like rerun those test files. So it's pretty clever. And so right now we have 40 tests running. It looks like my code is not actually working because I would expect new search params to call that. So now I'm thinking I may have to run something like this. Globals. In your test files, just puts each of these methods and objects in the global environment. Yeah, okay, that's not what I was looking for, actually. Just mock, I don't know, mock URL search params. I guess I could spy on it. Okay, so this is how this person does it. And I know that I'm looking at Jest code right now. But Vitest is very much based on Jest. So it looks like, yeah, they're kind of doing the same thing too. So that looks the same. I'm going to comment that out. Well, let's try this. Class fake whatever whatevs. Fake whatevs is a class. It's going to have a constructor and it's just going to pass whatever it's constructed with here. And I'm even going to take it a step further and say console log what? So I expect at this point that when this gets instantiated, this gets imported from URL search params, which then actually gets mocked, hopefully. And then this constructor takes over for that constructor. It looks like we don't have anything screaming at us. So that's unfortunate. Okay. Fine. We'll do one better. For all. So we'll see if we have to do it this way. Before all should take a function that runs before everything else. And now I want to overwrite URL search params. Rerun our tests. Man, it's still not working. This is such a silly test because it really doesn't do it doesn't even do anything. So why do I have to write a test for it? That's a good question, Austin. Let's not write a test for it. Let's skip that. Delete it. And let's move on to our actual source code. So we have a method here called create API. Or a function here called create API. So let's copy that to, oops, what did I do? Let's copy the function to the exact same place, rename that to copy api.test.js. That way our tests and our code live happily right next to each other. And then we can copy some code from another test just so we have it there, nice and easy. Don't need node fetch. We want to import, what is that? The default export, yeah. So import create API from /create API. We can get rid of that. We can get rid of that. I believe because I'm hoping that HTTP request will, I probably shouldn't count on that. Let's call this as well. So we're going to create another mock for node fetch. The reason why we want to create a mock for node fetch is because you generally want to avoid making actual HTTP requests during tests for a number of reasons. One, if you're going to wait on HTTP requests to go out and come back, that's going to slow down your test. Two, it may introduce buggy code, like false negatives into your test, because if that HTTP request goes out and somehow it experiences a network error, you're going to get a failed test response when in reality, you're not trying to test the network response. You're trying to just test that the fetch call is being made. Once a fetch call is made, you can kind of disregard the fact that it goes out to the server. This isn't always the case. It's just most commonly the case because it reduces the brittleness of your tests and it increases the speed. However, every once in a while, you may want to actually send network requests to an endpoint, because every time you use a mock, you're creating one other opportunity for disparity between how things actually work and the code that you use, the fake code that you use in place of it. Does that make sense? I think Ben fell asleep. Called it. Anyway, let's keep going. So we're going to mock node fetch because we know that node fetch, we know that create API uses HTTP request. We don't want to be there. We know that create API uses HTTP request, and HTTP request uses node fetch. So we will nip that in the bud and not send any actual requests over the server. So next we want to actually execute create API. So we'll start with this line here. This is the first test that we want to make sure that Open Weather API and GeoAppify key API keys are being passed in. So we'll say create API is the test suite that we're creating, and then we'll say, I don't know. I think I'm just gonna test it like that. So test that it what do I want to say? It uses, well, actually I guess it returns an object with two methods, right? Like that's sort of the first test. And then I'll get into writing tests for each of these individual methods. So yeah, it returns an object with API methods. So we're going to say create API equals create API. We really don't even need to pass in the API keys, because just creating the API isn't going to actually use them. So we create an API and then we say expect API to what? To be to call. I feel like to equal is probably good. So it equals. Huh. That's cool. I didn't know you could do that. So it looks like I can say I expect my API to equal an object, and this object should have one call and get geolocation, because we have one call and get geolocation. And then it looks like expect .any. I can say that I expect this one call to be a function rather than just passing in an empty function like that, like it's just a method. Let's see how this looks. I'm going to try these two. My tests automatically run and re-render. And then, okay, so we get, okay, that makes sense. Can't grab that property if it's undefined. So we at least need to pass in an object there. And I am going to leave that as an error. I'm not going to check that it's an error, because technically this is the sort of error that TypeScript would help us catch. We can see that the type definition for create API is that it expects an object, and that the object should be, should have these two properties. So I'm going to leave that as is. And then we have, oh, there was our test. I wanted to see what that looked like. We have a failure here. And so it's supposed to deep equal one call, function one call to equal. Okay. This is what I got. This is what I was expecting. Or no, this is what I got. This is what I was expecting. Get geolocation. So this one looked like it passed. Okay, so this is not the way to do it. I think I've got it fine there. What is this complaining about? Do not add spaces between braces. If I do that, you're going to complain? You're lurking today. All right. Yeah, take care of your work. I'm just hanging out, trying to get these tests to work and also get rid of all these red squiggly lines. Unfortunately, when I hit save, my formatter likes to add those back in, even though there's no red squigglies. That's so annoying. I hate when that happens. So let's see how this is going. Okay, so you're still complaining about not having deep equality. Grr. Let's see what other methods we have available here. I expect this to instance of less than contain, no. To have property. Well, I think I can't do this the easy way, so we're going to have to do this a more complicated way to say that we expect this to be object. Yeah, to be object. Okay. And then we expect API dot one call to be a function. Sure. And API get geolocation to be a function. Cool. And that should be good enough to pass our tests. No, it's not, because to be object, invalid chai property. Great. Chai API expect object. This is one of the annoying things. Expect. Well, I should probably go right to the Vitest docs, actually. So, nope. Vitest. So the API, expect it to be instance of a object might work. To have property, that's probably what I want. Let's see, type of. All right, well, let's try this to be instance of, and I'm going to see if I can say that this is an instance of an object. And then I'm going to say, let's say type of that to be function, which I'm not sure if that's even going to work, but we'll see. All right, let's try that. This is where tests get painful, but it worked. Great. So we know that we expect the returned API to be an object with two methods on it. And this is a pretty good test coverage because we don't just want to check that it's defined, because it could have been like a string or a number or something. By checking the type of, we can see that this is a function. I guess that's good enough for me. Cool, let's move on. The next test is going to be, I'm going to go in here and put another describe block. Did I spell that right? I think I did. And we're going to say API dot call. It's okay that create API doesn't actually technically have a method called onCall. Is it though? Because it could eventually have its own method. Anyway, this is just something, I'm going to put it as a separate space. So it's okay that these are not exact, because it's just a way to communicate what the test suite is supposed to be testing. So next I can say, what can I say? Well, that's what the test does. Yeah, sure, let's cut that in there. So I think what I'm going to do is actually, I'm going to set up some fake data to begin with. So const, let's say, what is it? Open weather, yeah, sure. Sure, I don't want lorem.word. I want internet dot, give me something useful. Give me an API key. Domain name, email. All right, fine. What is lorem dot lorem? Sure, lorem.word. Cool. And then we're going to say the other one is, you going to help me out here? Yes, thank you. All so that I don't have to type in some letters. Okay, so we've got our two API keys, and then we're going to say const, yep, API is that. Here, I'm going to actually remove this locally scoped API, get rid of that. And then this test is still being applied to this instance of an API. And then I'm actually going to say this is API.onCall. Cool. And I'm going to rewrite this to look more like what the file is. Cool. So then when this is called, let's see. I'm going to say, no, man, that thing always gets in the way. All right. So we're going to say API.onCall. We're going to call that with, what am I doing? The question is, the only question that I really care for is, well, I guess a couple of things. That it calls test.concurrent. That's what I do. So I want to describe my test here and say it passes, I don't know, default parameters to open weather API. Sure. Okay, so then what we'll do is actually execute our method without any parameters. And what I expect is, oh man, we're gonna have some work to do here. So this is going to be an asynchronous execution. So we're going to say async, and we're going to say await that, and then I do expect node fetch to be called. So let's say import fetch from node fetch, right? That's what we were doing over here in my test file over here. Oh, actually going to rename this to just fetch. Import fetch. Cool. Delete that. In my test over here, we have that written up correctly. Import fetch from node fetch. We are mocking that, so I expect fetch dot to be called. We'll just start with that. This async is in the wrong place. Should be there. And I think that is my test. So I kind of expect this to fail. Yep. And this is exactly why. So this is actually good news. Because this confirms to me that my node fetch is working. Essentially what's going on here is in our code, we're saying, hey, when you call this method, build up these query parameters, build up our response, which uses HTTP request, which itself uses fetch, right? Okay. Or uses node fetch. And node fetch behaves very much like fetch. So when we pass this URL in here, we expect to get back a response object, which is why we can grab JSON from that JSON.response method. So the fact that our test is saying we can't read properties of undefined, the reason it's saying that it's undefined is because when I mocked the node fetch API or the node fetch package, I'm giving back a default function that does not return a response object. So I'm actually going to have to rewrite this mock to say mock resolved value. And my mock resolved value can, and again, it has to be a resolved value, not a return value, because this is a promise. So this is the resolved value of this promise. And the resolved value itself is going to have to be an object with the JSON method. So I could create a custom response object, or I can just pass in an object here, this resolved value, with a method called JSON. And we're going to say that's also going to be a mock function. Here's where we get into a little bit of the dicey stuff with tests. So if you don't understand everything that's going on here, don't worry about it too much. And none of that is what we actually care to test. But I probably should do something with that. Is I'm going to say like pull all these things up here and say const mock JSON equals, can I do faker dot fake JSON object? Let's see if I can do fake JSON object. Faker.js. The website. Oh, fakerjs.dev. Here we go. So with Faker, can I do just an object? Address. I mean, I guess I could do an address. No, because I don't have to. Nothing it gives me back is an actual object, huh? Well, okay. We're gonna say Faker mock JSON is going to be an object with I don't know. Yeah, sure. Favorite animal is going to be Faker dot animal dot dog for sure. Random dog. Favorite animal. Okay, so that's some mock JSON. And then we're going to say, hey, when our API request comes back, oh, man. Okay. You know what? I'm getting way too complicated here. We don't need to do this. Here we go. We're just going to pull this up, and move that back down how it was. So this is the first thing we see, that we're mocking node fetch. The reason why I don't actually care. Oh, I do kind of care what this returns. Do I care what that returns? I probably care what that returns. All right, back to the drawing board. Let's redo all that and say, yeah, we'll leave it like that. So this is the mock JSON. That's okay that it's always going to return the same thing. This is going to say mock resolved value is my mock JSON. And we'll leave it like this. No, I'm going to say random dog is going to be this. Okay. JSON is going to be favorite animal, random dog. So why are we doing this? That was a lot of going back and forth on how we're going to design this test. The reason why is because I eventually know that while I run this test, I'm eventually going to call, make this API request and get the response. And then I'm going to call this method and get this method. And I want to be able to test that what this method returns, or what this method returns, is being returned by this function as well. Hope that's clear. And by creating, like basically passing in or defining the random data up here, and then passing it in here, we should be able to basically in our test directly reference this random dog value. Hope that's also clear. That was kind of not so great explanation, not good talking by me. But let's do this. So let's get this actual test written.
So now I expect fetch to be called. Let's run this again. Open weather API equals cannot access random dog before it was initialized. Great. That's unfortunate. So everything I just explained actually doesn't make sense, because the way tests work is this is all going to get hoisted up way before, and we can't access this before it's initialized. I wonder if I can do that with var, if that will actually fix that issue. Oh my gosh, it actually does. That's cool. That's an interesting little tidbit of JavaScript knowledge, is hoisting. So that's pretty cool. Yeah, let's make it a little bit more clear what's going on there by moving this up. So this makes sense, at least a little bit more in logical terms, that this gets hoisted up so that it's then available to be accessed here. If that doesn't make sense, sorry, I'm not going to go into it further today. But now we can access this. Cool. So let's write our next test. We're here. Let's see random dog, make sure that we can access it in a way that makes sense. So I do expect this to be defined now. Okay, cool. Yep, we've got our random dog. Excellent. That we can access in our test. And then we're going to say, call that, expect fetch to be called. And then I'm going to have to spy on URL search parameters. Oh, I have a bug here as well. This URL search params is actually going to have to come in from my URL search params package. Like I have here. Yay for writing tests. Cool. Okay, at the end of the day, I expect fetch to be called with, and something I like to do when I write my tests is just throw in a fake value there so that my tests will rerun and it will tell me what I should be expecting it to be run with. And that is the value that I want to pass in. So I expect it to be called something that looks like this. Well, might as well reuse some code. App ID is that. That is what I expect my test to be called with. Imperial units and my open weather API key. And in fact, it's working. And then the next thing that I need to make an assertion for is, well, that's it for this test. I'm making an assertion that it's passing my default parameters into my fetch request. So now I'm going to write a very similar test that passes custom parameters. It passes custom parameters to
Not Open Weather API. Yeah, Open Weather API. Okay, so we're going to do the same thing, except here we're going to pass some parameters to it. So this takes an object with lat, lon, and units. And we're going to say const, or whatever, lat equals faker, not random number. Well, sure, random, not random number. Data type dot number. Lon is data type number. And then, oh man, we've got a bunch in there. Language and units. Units is going to be faker dot. I'm doing this all wrong. This should be pulled out and it should be params. And then const params should equal an object. We do that. We do that. The reason why I pulled those parameters out of the method is so one, it's easy to just stick right into the API call, and two, so that we can reference these values later, particularly when we're building our query here. So I've got my units. Faker, I want helpers dot randomize. Metric imperial standard, sure, why not? Exclude faker randomize. What are you going to tell me to randomize, faker? Current minutely. Oh, wow, okay. It actually pulled that from the API. That's really impressive. Exclude, and then, yeah, lang. Lang is faker lorem word. Cool, that's my parameters. I think that looks good. And then I would expect my API to actually be called exactly with this, dot, 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 parameters, and always have this API ID on there, so that when we call this, all of these values should actually exist in the query string parameters. So let's see if we wrote that right. We have a failed test. Interesting. It passes the default parameters fine. It passes the custom parameters is not working as expected. So, oh, this is the problem. The problem is now I've called this twice. So because I'm reusing this same API that I'm creating, it's reusing, the methods are being reused in those mocks. So instead of that, I think we're going to do this kind of the easy way. We're going to say, when we write tests, we have the option to use this function or method called before each. And what before each does is it takes a function that you can describe how you want to, or some function you want to run before each of these functions, other functions run. Yes, we are definitely learning today. Sorry for the late response on that. But before each of these gets set up, what I'm going to do is I'm going to copy this code or cut it. I'm going to say let API, so I define my variable, and then we're going to update that variable every time before any of these tests run. And maybe I don't want to do that actually. I think what I want to do is before each, I want to call API dot geolocation dot that should be a mock. What am I doing with my life? Oh, that's the problem. Okay. It's actually not a problem with API. The problem is with our fetch. So fetch here is the mocked. Well, it is a mock. So what we want to do is reset the mock every time before it's called. So we want to reset mocks. Is that it? Let me see here. Well, I can see if that actually is running. Reset mocks is not a function. Okay, let's look for reset, mock reset. Okay, that should do it. Let's see how I'm feeling about this. Didn't do it. It did work. Is it? No, got it. Okay, not mock reset, mock clear. Oops. Okay, still failing. Why is this failing now? So this is what we're getting, and this is what we're expecting. Interesting. I'm close. I've got the lat is correct. The ln is correct. The units got out of order and then exclude. Okay. This is easy enough to fix. Because this, I guess the order kind of matters. I can fix it this way by adding the units there and then saying that I expect the units dot parameters, or the units to equal parameters dot units. That's still not going to work. Close. Oh, that did work. Did that work? It did work. Okay. So the challenging thing here, yeah, that does make sense that it worked. Okay. So that was a challenge. That was a lot of stuff that we covered today. This was a complicated unit test to write. So I hope that you were able to kind of stick around and understand what was going on. I'm going to do a brief overview of everything that we covered. I think it's a good idea to start as a QA tester solely to transition into a software engineering role. It kind of depends where you want to go ultimately. I think there are definitely people that make that transition, and having a background as a QA engineer is going to give you, well, every background that you get is going to give you an advantage in some sense. I have a background in kinesiology, so like physical therapy. So there's a certain advantage that I have going into software development that I picked up from that. But it depends what you're looking at, right? So if your background is as a QA engineer, you're going to have an advantage in understanding all of the different errors that could go into writing a component or a function, right? And you might be better suited for addressing those errors or edge cases, or maybe you'll be better at writing tests and things like that. In general, though, I don't really think that is like an advantage for a general purpose developer. I think it's going to be different for everyone. It's a big, it depends. But I think if you're just asking of like broad strokes getting into web development, what's the best way to transition into that career? Starting as a QA engineer, if that can be your first job and you get a job in a tech company as a QA engineer, and you can get in as a QA engineer, but you can't as a software engineer, then sure, it might allow you to get in and then make a horizontal move into software engineering. But I really think if you know you want to go into software engineering, just focus on that. Free Code Camp is a really good resource, freecodecamp.org, to get some skills, to get into, be able to create some websites and write some software. And once you just like keep building a lot of stuff, then yeah, you can get into some internships or some entry level positions. Keep building a portfolio, just keep building stuff that you can show off to the world. I think that's the best way to get into software engineering. But if you like QA, if you find that you're actually interested in writing these tests and making these assertions, then absolutely explore that and see if you're interested, because there's a whole bunch of different things you can do with software. And if this is the sort of thing that piques your interest, then absolutely, listen to that and try and do the things that you enjoy, because it just makes the job a lot better when you enjoy it. So anyway, going back to just the overview before I finish off today, the things that we covered, we got a little bit back into mocking dependencies so that we're not running flaky tests or sending HTTP requests over the server or over the network. We did a little bit of fake data generation. We learned about running the same function over and over before each test runs. So in some scenarios, you want to set up every single test with the same clean slate, so that previous tests don't have an impact on the results of subsequent tests. So before each is a pretty common like lifecycle hook or something that you can tap into, that is a tool you can use to clean up data or initiate data or whatever. In this case, we're using it to clear an existing mock. So because we're mocking the fetch API, and every time that we access that fetch API, it's going to keep track of all of those calls. We want to make sure that we clear it and basically reset it back to an initial state, so that on the next test, the previous test doesn't interfere or doesn't provide fake data or like bad data, if that makes sense. And then beyond that, we learned a little bit about asynchronous tests. So if you're ever doing like, if you're ever working with promises, you may have to use the async await pattern to wait for a method to finish before you run your assertions. And then, yeah, we got a little bit more into generating fake data and testing some things out. So I'm going to get rid of this. I will be pushing up this code shortly. And if you liked it, please, share, follow, like, do all the things. And I will be back on tomorrow at 3 p.m. Pacific Standard. I will see you there.